Knowing two components of a cone, we can compute for the others. Check how this example is solved here in Mathematics of Engineering. The problem states that given the surface area of a cone to be 250, we are to determine its volume if the cone's height is 8 units. To interpret the given, we can note the surface area as 250 square units. By surface area, we meant taking the area of the base and the lateral area. Mathematically, we can write this as pi r squared for the area of the base and pi r L for the lateral area. Note that we have a single equation with two unknown variables, r and L, so we need to reduce the unknowns. The other given is 8 units as the altitude or height of the pyramid, notated as h for this example. The height is used to create a function relating r and L, so as to reduce the variables in the first equation. To relate r to L, we use a triangle with base of r and height of 8 units as given. L, or the slant height, is then the hypotenuse, which can be solved using Pythagorean theorem. L is then the root of r squared and 8 squared. L is simplified as the root of r squared plus 64. Having L as a function of r, substitute this into the main equation. 250 is equal to pi r squared plus pi r with the root of r squared plus 64. Factor out pi and have 250 as equated to pi times the quantity r squared plus r with the root of r squared plus 64. Divide both sides by pi, making the function 250 over pi as equal to r squared plus r times the root of r squared plus 64. Now we have a single equation with one unknown, which means through algebra, we will be able to solve for r. Transpose r squared to the other side, which brings 250 over pi minus r squared as equated to r with the root of r squared plus 64. Take the square of both sides and be careful that the square of the left term will make up a perfect square trinomial. For the square of the binomial, we take the square of 250 over pi. Subtract double the product of the first and the second terms. Then attach the square of the last term, r squared. For the right side, distribute r squared among the terms. So by computing, we get 6,332.5740 as equal to 159.1549 r squared. Then the last term of r raised to 4. This is equal to r raised to 4 plus 64 r squared. Cancel out r raised to 4, then collect all terms with r squared, thus having 223.1549 r squared as equal to 6,332.5740, where r squared is 28.3775 after dividing 223.1549. Take the root of r squared, giving r as 5.3271 units. Upon knowing the value of r, compute for the volume from the function of 1/3 pi r squared times h, which becomes 1/3 pi times 5.3271 squared times 8. Simplified as 237.73 cubic units.